express their task graph in a way that the compiler or runtime system can kind of slide around this decision point as to where you create the union and where you so you still want your applications written in a single level programming model, even though you have this one kind of upfront dynamic programming model and this actual dynamic add-on resource model. So I don't actually, I mean, that's obviously open question. I would assume, unless CJ, you have a solution to that, I would love to hear it. It'd be really cool. But that's what I find most interesting about this, from our perspective, at least.
I think there's an opportunity actually to a hybrid version of that is if you know a priori, right, which is a specialized case, what some of the most likely opportunities are, right, directions you go. I'll probably end up with something a lot like this, or at least close enough to this that I could pre-instantiate something that'll be good enough. Then I can take the cost of the pre-instantiation off of that critical path, and then after I've done, in our example, my first phase, the first time through, I may have no templates for what it is that I want to do. But the second time through, I may have already created a template, and I may have actually created an instantiation, and I may be able to just customize that to whatever it is that I need. And I may, even if the instantiation isn't quite it, I may do another version of the template graph, which is a generalization of the last time that I used. So I thought, oh, well, I might also take this path with a reasonable likelihood. And so I'll augment that templated subgraph a little bit and then instantiate that generalized version and see if that works for me. And if I'm going to have 1,000 iterations, eventually it may converge on something that is close enough. Most of the time I hit my quote-unquote cache of pre-baked instantiations. And so I'm going to do pretty well most of the time. If it's totally random what you're going to do and it's totally different from time to time, then obviously that approach isn't going to work.
Yeah,
but
absolutely.
It's a total heuristic, right? It's totally dependent on the circumstances as to whether that is interesting. And if you know enough about the math, you may be able to pre-guide it in that direction, or you may develop some runtime heuristics that can figure out how to do that. Clearly, there could be some good papers or even PhD theses in there, right?
Yeah, actually, one of our team members, Jonathan Lifflander, Dharma, led a paper that we sent to SC early this year. I'm not sure if it's been accepted or rejected yet, as supercomputing. I don't know if everyone here is HPC or not, but that we sent to the supercomputing conference this year, basically exactly on that, on optimal versions of caching dynamism in iterative applications, for iterative task graph applications. And I would, I don't want to summarize him too much, but it boils down to finding where which of these kind of branch statements you can cache reasonably, and when you need to be able to throw these things out, and doing so in reasonable time. So
that was an SC18 paper?
It's an SC18 paper. I don't know if it's been accepted or not. Jeremy can probably tell us more.
Very much not.
Very much not? Oh, okay. Well, we may clean it up and put it on archive at some point or something like that. But
I was just I put in my working notes, Jonathan Lifflander has an SC18 paper submission on dynamic caching of common subgraphs. If you'd rather I strike that from the notes, I can, if you don't want to talk about that. Is that your preference, Jeremy?
Oh, no, it's fine. We ran out of time on the paper, which is why I got rejected. No, I think it's a good paper. We tried to do too much too fast. But you can leave it in the notes.
Okay. Okay. More ideas on this?
Do all the dependencies needs to be satisfied before actually executing a subgraph in the current context?
Let me restate your question to see if it's what I think it is. Some people call that strict with the dependencies of can I issue work before I know that it's totally ready to run to completion? Is that your question?
Right. So I was thinking about level correcting algorithms where, or for example, if I take coloring algorithms for graph applications, when I'm coloring a vertex and I just have to first in the pre-execution stage, I have to come up with this DAG where there will be a predecessor successor relationship, and then each vertex will wait for all the predecessors to be colored so that it can find out which is the minimum color. But there can be level correcting algorithms where that particular vertex doesn't have to wait for all its predecessors to accurate their color, and it can optimistically go ahead and find the current minimum available color, and later on it can uh, refine that color as it gets updated results from its predecessors. So I was wondering whether this kind of execution will be is it supported in the current context?
That's Sassoon, right?
Yeah.
Okay, I'm not familiar with that. Did you call them level creating algorithms?
Level correcting.
What's the level what? Sorry? Correcting?
Yeah.
Okay. Oh, for color. Okay, that makes more sense. I'm not familiar with that. I'm sure others in the company I work for would be.
I'm pretty sure Andrew knows about it.
Okay. And that's interesting. I think that would introduce a new set of requirements to enable that, because in general, I'll just label it a fear, that if you enqueue something for execution before all of its dependencies are satisfied, one, you incur extra complexity to figure out whether the dependencies are satisfied, and a second thing is that you may lead to deadlock, where you could start to grab and hold resources and get into deadlock.
That's possible.
So there are cases where that could be worth doing, but yeah.
But if we are executing based on DAG structure, some DAG structure, then I would say, at least from that perspective, there wouldn't be a deadlock, because everyone is forwarding everyone is propagating the computation forward in the DAG. So there is no possibility of going into a loop.
Okay. Maybe we could communicate offline.
Sure.
You could post or send me or others some more information on that, and we can talk about it. That sounds interesting.
I can do that. Thanks.
And in particular, what is it that suppose this is the subgraph worth of work, and not all of the work inside that DAG is data ready? You want to start executing, or is it the key? It sounds like the key thing is that you can execute it the first time, but it may not complete because it's going to keep running for a while, and it has a dynamic dependence. There you go, rather than dynamic creation of the graph on more work that has yet to come in. You know that it'll eventually terminate, but you don't know when. Because you're still waiting for other work to complete and stop sending stuff, and that other work will somehow eventually signal, hey, I'm totally done now, I'm not going to give you any more input, and so you're free to terminate. Is that the issue?
Right. And one thing I was concerned about is that what granularity for computation are you considering here? Is it in terms of vertex level when you were talking, or in terms of a subgraph, or because if this, I mean, in terms of level creating algorithms, I was thinking in terms of a vertex, and it may be very expensive. It can become expensive if we are executing in this way, where we are scheduling one vertex at a time and see how much dependencies has been satisfied. And even if it's, the partial dependencies has been satisfied, that vertex will just go ahead with whatever information it has right now and retire itself for later execution. So that can get expensive.
Well, I guess my gut would say, as a programmer, you're free to express the dependencies that you care about and not express the dependencies that you don't wish to expose to the scheduler. And so that you can express the dependencies that really are preconditions before any of this subgraph begin. And then inside the task, you could manage using sideband communication, global data, structures, whatever, your own signaling of, are you done yet? And just tell the rest of the runtime, trust me, I know what I'm doing, and I'm not going to tell you what I'm doing, but I'll terminate just fine, thank you very much. And then that would just work.
So that actually raises another interesting question, which we have been working with Andrew and others, is that termination detection. So this is one important aspect here for asynchronous execution, where we have to decide whether this tracking of termination detection, does it have to be in the programmer level, or is it in the runtime level, like how many activities going on and how many has been finished? Because as you said, somewhat we need to reach into some global quiescence where everyone knows, like, okay, everyone is done. But if we so in the level setting algorithms, if we're going level wise, we always know, like, we are always going forward, and everyone knows, like, after some level has been done in execution, then the algorithm is finished. But in asynchronous execution, we can go back and forth in different levels. So this is another important aspect, the termination detection.
Okay. And I think these are interesting use cases, and it seems like for those it'd be helpful to write them up and then just look at how it is that you could use relatively simple infrastructure to be able to handle those cases. And instead of trying to solve all the problems down at the plumbing layer, to leave a client runtime the flexibility, and the application itself the flexibility to come up with appropriate solutions to those using low-level plumbing's building blocks.
I agree.
So those would be great. I can again work with you offline too. There are places elsewhere on this Model Auto site where you can put in some usage models, and it'd be great to, if you want to put those in there.
Yeah, we can definitely do that. Well, we actually submitted a paper to SC, but we got rejected. But I think there are some use cases there, so I can forward it to everyone or upload it to somewhere.
Yeah, poke around on the Model Auto site and see if it's obvious enough to you where to add some usage model cases, and if it's not, just ping me and I'll help with that.
Okay, thank you.
Okay, great. And I think we've completed the time that we have. So we can next time go through more of this content. I welcome, because we're plugging right along with this, I welcome more feedback on this earlier. So I posted this content in the minutes. I'll have a link to it. So you can go and look through some of the other kinds of things that are here about how we were looking to make this stuff work. And you can offer some feedback offline, and then we can talk about that some more next month. Okay, any other closing comments?
Thanks,
Okay.
CJ. Appreciate it.
Thanks very much.
Thanks, everyone.
All right, and some folks were interested in talking a bit about follow-up to the workshop, so I'll hang on the line, and if anybody else wants to talk about any of that, I'll be around for that. So thank you much.